There is a machine inside your chest that never takes a day off. Every minute, it moves blood through a precisely choreographed circuit. But here's the strange part. The heart doesn't just push blood forward. It has 4 gates that must open and close at exactly the right moments. One wrong direction, one gate that cannot open fully, and the entire system can be disrupted. Tonight, we're going inside those 4 gates, and by the end, you'll hear your heart beat differently. Think of your heart as a pump, but not a simple one. It is divided into 4 chambers. The 2 upper chambers, the atria, receive blood. The 2 lower chambers, the ventricles, generate the force that sends it onward. And between these chambers and the major arteries are 4 valves. Their job is deceptively simple. Let blood move forward. Stop it from flowing backward. The right side sends oxygen-poor blood toward the lungs. The left side sends oxygen-rich blood toward the rest of the body. The valves don't need a nervous command telling them when to open. They respond primarily to changes in pressure. When pressure pushes the right way, a valve opens. When pressure reverses, the valve closes. That simple principle keeps the circulation moving in one direction. Our journey begins on the right side. Blood returning from the body enters the right atrium. It has already delivered much of its oxygen to tissues, so we visualize it as blue. From the right atrium, blood moves through the tricuspid valve into the right ventricle. The name comes from its 3 leaflets. Picture 3 flexible doors meeting at the entrance to the ventricle. When the right ventricle relaxes, pressure inside it falls. The tricuspid valve opens. Blood moves downward. Then the ventricle contracts. Pressure rises, and the 3 leaflets snap shut. That closure is critical, because the ventricle is now generating enough pressure to eject blood forward. Without a functioning tricuspid valve, some blood can move backward into the atrium instead. The valve is therefore more than a doorway. It is a one-way checkpoint between 2 chambers, and the next gate has a very different job. Now the right ventricle contracts. The blood has only one intended destination, the lungs. But before it can leave the heart, it must pass through the pulmonary valve. This valve sits between the right ventricle and the pulmonary artery. When ventricular pressure rises above the pressure in the pulmonary artery, the valve opens. Blood surges forward, and then something remarkable happens. As the ventricle relaxes, pressure inside it drops. The pressure in the pulmonary artery becomes relatively higher. That pressure difference pushes the valve shut. No motor, no electrical command, just fluid pressure acting on living tissue. The blood then travels to the lungs, where it can release carbon dioxide and pick up oxygen. So the right side of the heart performs a very specific task. It sends returning blood to the lungs for gas exchange. And once that blood is oxygenated, it comes back to the other side of the heart. That's where the system gets more powerful. Now we reach the left side of the heart. Oxygen-rich blood returns from the lungs and enters the left atrium. From there, it has to pass through one of the most important valves in the entire circulation, the mitral valve. The mitral valve sits between the left atrium and the left ventricle. Unlike the tricuspid valve, it has 2 main leaflets. As the left ventricle relaxes, the mitral valve opens. Red blood flows into the ventricle. Then the ventricle begins to contract. Pressure rises rapidly. The mitral valve closes. And this is where the engineering becomes especially impressive. The valve's leaflets are connected by thin strands called chordae tendineae. These connect to papillary muscles inside the ventricle. Together, they help prevent the valve leaflets from being pushed backward into the atrium during contraction. Think of this system like a parachute held by suspension lines. The lines don't pull the valve open. They help keep it from flipping backward when pressure suddenly rises. Now the left ventricle is loaded. The blood is oxygen-rich. The pressure is building, and there is only one gate left before that blood can reach your entire body. The left ventricle now contracts with tremendous force. Its target is the aorta, the major artery that distributes blood throughout the body. But first, blood must cross the 4th gate, the aortic valve. When pressure inside the left ventricle rises above the pressure in the aorta, the valve opens. Blood accelerates forward, through the valve, into the aorta, and outward toward the brain, the muscles, the kidneys, the skin, virtually every tissue that depends on circulation. Then the ventricle relaxes, pressure falls, and the aortic valve closes. That closing prevents blood in the aorta from flowing backward into the ventricle. So if we trace the complete route, the pattern becomes almost elegant. Body to right atrium, through the tricuspid valve, into the right ventricle, through the pulmonary valve, to the lungs, back to the left atrium, through the mitral valve, into the left ventricle, through the aortic valve, and finally, back to the body. 4 valves, one continuous loop. And now you can understand a sound you've heard your entire life. Lub-dub. The first heart sound, often called S1, is associated mainly with closure of the atrioventricular valves, the tricuspid and mitral valves, as ventricular contraction begins. Then comes the second sound, S2. It is associated mainly with closure of the semilunar valves, the pulmonary and aortic valves, as ventricular contraction ends and relaxation begins. So your heartbeat isn't simply the sound of muscle squeezing. Part of what you're hearing is the rapid movement and vibration of structures surrounding valve closure. The sequence happens again, and again, and again, for your entire life. 4 valves coordinating with pressure changes hundreds of thousands of times across an ordinary day. And normally you never notice any of it. But what happens when one of these gates stops working normally? There are 2 basic problems to understand. The first is stenosis. A narrowed valve doesn't open properly. The opening becomes smaller, forcing the heart to generate more pressure to move blood through it. The second is regurgitation, sometimes called valve leakage. A valve doesn't close completely. Some blood moves backward when it should be moving forward. Both problems can range from mild to severe, and the effects depend on which valve is involved, how significant the abnormality is, and how the heart and circulation respond. Some people may have few or no noticeable symptoms. Others can develop problems such as shortness of breath, fatigue, chest discomfort, dizziness, swelling, or reduced ability to exercise. Those symptoms can have many causes, so they shouldn't automatically be blamed on a heart valve. If a person has concerning or persistent symptoms, medical evaluation is important. Doctors can use tools such as a stethoscope and echocardiography to investigate how the valves are functioning. The point isn't to fear these gates, it's to understand them. Now step back. The heart isn't operating 4 independent doors. Everything is synchronized. When the atria help fill the ventricles, the atrioventricular valves are open. When the ventricles contract, those valves close. At the same time, the pulmonary and aortic valves open so blood can leave the ventricles. Then the ventricles relax. The outflow valves close. The atrioventricular valves open again. The cycle repeats. Open, close, fill, eject, again. The valves themselves don't need conscious control. Their movement emerges from the changing pressures inside and around the heart. And that's the remarkable part. The system doesn't need to think about every individual movement. Its anatomy and physics do much of the work. 4 gates, 4 chambers, 1 circulation system. The tricuspid valve directs blood into the right ventricle. The pulmonary valve sends it toward the lungs. The mitral valve fills the left ventricle. And the aortic valve launches oxygen-rich blood into the body. None of them pumps the blood by itself. They control the direction. And that may be the simplest way to understand the heart. The muscle creates the pressure. The valves enforce the direction. Every heartbeat is another cycle of that invisible choreography. So the next time you hear lub-dub, remember, you're not just hearing a heartbeat. You're hearing 4 gates doing their job. If you want more journeys inside the human body, subscribe.